it's Mrs. Nandor, and in this video we are going to look at how we graph density and how we can use density information to determine if something will sink or float. So let's talk about graphing first. So we won't always get just a set of density data. Sometimes we'll see a graph of density, and so we collected something similar in lab. And so when we graph density, we always do mass on the y-axis and volume on the x-axis. And so we get a line to represent our density. Now, what about that line represents density? Well, we know that density is mass over volume. What else about this line is mass over volume? Well, if we look at our axes, our mass is on our y-axis. Our volume is on our x-axis. Well, y over x in math class is slope. So the slope of a line from the graph for a density graph is the density of the substance. So the slope equals the density. So we can calculate that by hand. This means we can draw a line to represent a specific density. We could have a computer program calculate the density for us by finding the slope of the line that it creates. There are lots of different ways that we can get the slope to determine the density. Now, let's look at if we had two substances on here. So let's say there's another substance we measured and its density information went like that. Okay, so which slope is greater, purple or blue? Well, the slope of the purple line is much steeper, so it's much greater than the slope of the blue line. That means the density of the purple is much greater than the density of the blue. So we can just look at this. Even if we didn't care about the actual value for the densities of either of these, we could look at this graph and say, oh, the purple substance is much more dense than the blue substance. And we know that visually just because we can look at the slopes of the lines. Purple line has a greater slope than the blue line, therefore it has a greater density. Let's talk about how we can use density to determine if something will sink or float. So in order for something to sink, it has to have a greater density. So usually when we think about things sinking and floating, we're thinking about them in some sort of liquid. Often it's water, not always, but often. So if we want something to sink in water, it must have a density that's greater than water. So if something has a greater density, it's going to sink. The opposite is true for floating. In order for a substance to float, it must have a density less than the liquid it's trying to float in. So for instance, if we wanted something to float in water, it must have a density less than the density of water. Now, we won't always use water as our liquid, but we use it often enough that it's useful to know the density of water. Density of water is 1 gram per milliliter. So if we want something to sink in water, it must have a density greater than 1 gram per milliliter. If we want something to float in water, it must have a density less than 1 gram per milliliter. Like I said, water won't always be the liquid, but it is often enough and it's useful to know the density of water. So if you're trying to decide if something's going to sink or float, you need to compare the two densities. Whichever density is less is going to be on the top. Whatever density is greater is going to be on the bottom.